Hi, what's up? Welcome to part 5 of Trigonometry, and today we're going to be focusing on proving identities and solving trig equations. Okay, now the textbook that we're going to use is Mind Action Series, Mathematics Textbook and Workbook. Okay, example 1. It says prove that 1 minus cos 2 theta over sine 2 theta is equal to tan theta, right? So if you want to prove identities, you must choose the side that you want to prove using, right? Obviously, we can't really come and say we're going to prove using that side, but we know we can come and choose this side, which is our left hand side. So I'm going to write left hand side, and I'm just going to prove and simplify that equation up until I reach what? I reach tan theta. Okay, so here is it. You are given 1 minus cos 2 theta over sine 2 theta, right? How can I prove this? Okay, so you can see that here you have 1 minus cos 2 theta, and here you have what? Sine 2 theta. So what we can do, we know that cos 2 theta is a rule, right? It's a rule. We can change it to be what? We can change it to be cos squared theta minus what? Minus sine squared theta. Okay, so divided by, what is sine 2 theta? It's also a double angle of sine, and it's also a rule that can be changed to 2 sine theta cos what? Cos theta, right? Okay, so now let's see, we're gonna remove by negative there to be minus cos squared theta, negative and negative sign, plus sine squared theta, all divided by 2 sine theta cos what? Cos theta. Okay, so look at this now. You have 1 minus cos squared theta plus sine squared theta. But according to one of the identities that we do in the revision of trig, that was our part 1, we know that 1 can be changed to be what? To be sine squared theta plus what? Plus cos squared theta. So I'm just going to change that 1 to be sine squared theta plus cos squared theta. Remember that identity. Then we have minus cos squared theta plus what? Plus sine squared theta. Can you see? Okay, so now these are divided by what? By 2 sine theta multiplied by what? By cos theta. Can you see? Then my cos squared theta and cos squared theta, they're going to cancel out each other. Then I'll be left with 2 sine squared theta. 2 sine squared theta. When we take sine squared theta plus sine squared theta, they're going to give us 2 sine squared theta. All divided by 2 sine theta multiplied by what? By cos theta. So basically what you actually do, you apply the rules that will enable you to change this thing up until you are able to solve it, right? Okay, we know that 2 sine squared theta is the same as 2 sine theta times what? Times sine theta divided by 2 sine theta cos theta. So 2 sine theta and 2 sine theta will cancel out each other. We'll be left with what? Sine theta over cos theta. And this is what? Is tan theta. Can you see? We managed to prove that indeed the left hand side is equals to the right hand side. And basically we just applied our double angle identity rules, and also that identity rule that you learned in grade 11, and also that was covered in our part 1 to say 1 is the same as sine squared theta plus cos squared theta. Then we added like terms like that up until we simplify to tan theta. Okay, let's now look at example 2, and it also says prove that cos 2x divided by cos x minus sin x is equal to cos x plus sin x. So this is some sort of a different identity as compared to example 1, right? So also in this one, I'm just going to choose the left hand side because it's the side that I can see it's quite complex, and I can simplify into cos x plus sin x. So the left hand side is cos 2x divided by what? it's divided by cos x minus sin x, right? Okay, so this is double angle for cos, and I know it can be changed into three things. Let me just write them for you. We can change it to cos squared x minus sin squared x, right? Or we can change it to 2 cos squared x minus 1, or we can change it to 1 minus 2 sin squared x. So when you choose which expression in which you can change it to, you must also check what you have on the denominator, so that you may have this connection, and so that you can be able to prove it, right? So definitely I'm just gonna choose an expression that is quite similar to what I have in the denominator, because I know this one can be factorized and we can cancel out each other and ultimately prove. Can you see? Okay, so for my cos 2x, I'm gonna change it to cos squared x minus sin squared x, all divided by what? By cos x minus sin x. Can you see? Okay, now I can factorize cos squared x minus sin squared x. Remember, when you had x squared minus y squared, you could factorize this into x minus y and also x plus what? Plus y. So also when you multiply again, you're just gonna get the same thing, x squared minus y squared. So same as cos squared x minus sin squared x, I can factorize it into cos x minus sin x and what? Cos x plus sin x. Okay, then divided by cos x minus what? Minus sin x. Can you see? So I have my cos x minus sin x there on top and on the denominator. So cos x minus sin x will cancel out with cos x minus sin x. I'm gonna be left with what? With cos x plus sin x. Now you can see that therefore the left hand side is the same as what? As the right hand side, because both of them are equals to cos x plus sin x. So in this example, really, I just wanted you to know that you don't just change. Remember, cos 2x can be changed into three things. You don't just choose any of the three things. You must be able to connect it with what you have on your denominator, so that when you change it, you'll be able to connect them and also cancel out each other and simplify your expression, so that you can prove what they want you to prove. Okay, let's now look at example 3. And A, it says prove that 1 plus sine 2a divided by cos 2a is equal to cos a plus sine a divided by cos a minus sine a, right? So in this one, one can either choose to prove with the left hand side, and you can actually prove this, or you might decide to prove with your right hand side. But with your right hand side, you're gonna use a different method, and I just really want to show you this this different approach that you can use. Okay, but for now I'm just gonna start with my left hand side, and I'll show you how you can prove this, right, using your left hand side. So we have 1 plus sine 2a divided by what? By cos 2a. Okay, so we know that 1 plus 1 it to be 1 plus sine 2a. If we change it, it's gonna be 2 sine a cos what? Cos a. That's the double angle of sine. Okay, so now we have cos 2a, right? So we can just change it to the standard one, which is what? Which is cos squared a minus what? Minus sine squared a. So that's the rule there. Okay, so what can I do now? I can change this one. Can you see? I can change 1. Remember the identity we did in part 1. It can be the same as sine squared a plus what? Plus cos squared a, right? Why am I changing this one? Because I can see under there is cos squared and sine squared. So I'm trying to connect what I have on the numerator and also on the denominator. So we don't just change, but really we want to connect the two. So plus 2 sine a multiplied by cos A. So under there I have cos squared A minus sine squared A. So which I can factorize, right, into what? Into cos A minus sine A, and this side cos A plus what? Plus sine A. Don't forget. Okay. So now look at this, right? Look at this expression that you have on the numerator there. Okay, look at it on the numerator. It's some sort of a quadratic expression that can be factorized, right? Look at this. Let me just write it properly for you. I can say sine squared A, then followed by plus 2 sine A cos A plus what? Plus cos squared A. And if I can relate this to sort of like a quadratic expression that can be factorized, look at this. I can write it x squared plus 2xy plus what? Plus y squared. Do you remember this quadratic equation? If I want to factorize that, I know that it's just x plus y, and it's x plus y, because x times x, x squared, x times y, xy, x times y, xy, xy plus xy, 2xy, and y times y, it's going to be what? Y squared. Same as this expression. It's in that form, right? So it's really in that form there. So what I'm going to do is I'm going to factorize this expression, right? I'm just going to factorize it. Okay, let me just put it there for now. And under there I have cos A minus sine A into cos A plus sine A, right? So I'm going to factorize that expression there. Obviously, it will be what? It will be sine A plus cos A, right? Cos A into what? We have a small space there. Okay, just gonna put it on top. It will be what? Sine A plus cos A into sine A plus cos A, right? Because I know sine and sine will be sine squared A, cos and cos will be cos squared A. Then to get my 2 sine A cos A is this and this. It will be 1 sine A cos A, and also this and this. It will be 1 plus sine A cos A. Then they will give me 2 sine A cos A. Can you see? Same as that expression that I just showed you. So they are divided by cos A minus sine A multiplied by cos A plus sine A, right? Okay, cos A plus sine A, it will cancel out with cos A plus sine A. Then you will be left with what? You are left with sine A plus cos A divided by cos, divided by cos A minus sine A. And you can see there that we just proven that the left hand side is the same as the right hand side. So basically it really wanted you to know how to factorize and how to relate this to factorizing quadratic equations. Okay, let me just show you how you could prove this using your right hand side. Okay, let's look at the right hand side. You are given cos A plus sine A over cos A minus sine A. So in order to prove that, you can see that from your equation, really there's not much that you can do. Actually, someone can say, what's the first step that I can do? I don't know what to do, something like that, right? To say, I just have cos A plus sine A, cos A minus sine A. What can I do more? You see? So in such cases, you must think of rationalizing probably the denominator, or you can choose to rationalize the numerator, right? Okay, so we use this method called rationalizing. And this method, think of it when you are just given a trigonometric expression that is in some sort of a fraction and you don't know what to do, right? It's like there's nothing that is coming on your mind, so you have to think of what? Of probably rationalizing the numerator, or also you might think of rationalizing the denominator, right? So if I want to rationalize the numerator here on top, right? So basically it's actually multiplying by 1, right? It's multiplying by 1. So in other words, I'll just come to this expression and multiply. If I want to rationalize the numerator, so I'll multiply by cos A, but I have to change the sign. Minus sine A divided by the same thing, cos A minus sine A. So that is called rationalizing the numerator. Why did I rationalize the numerator? How do I see that I've rationalized the numerator? Because I've multiplied with the numerator, but I've just changed the sign. And this thing, it's still 1. So we are not actually changing anything, because when you divide those two, they're going to give you 1. So you're not breaking any math rule. It's just called, it's this method of rationalizing, right? Okay, so really, I'm just going to rationalize the denominator or the numerator, right? So myself, I would prefer to rationalize the denominator. So I'll multiply with my denominator, but I have to change its sign. So it will be sine A there over what? Over cos A plus what? Plus sine A. So I'm just multiplying with 1. So I haven't changed anything. Can you see? So now after doing this, I can multiply my numerators and also multiply my what? My denominators. So when I multiply my numerators, it will be cos A plus sine A into cos A plus sine A. Can you see? Okay, divided by what? Divided by cos A minus sine A. It's being multiplied by what? By cos A plus sine A, right? Then I can expand. Can you see? So my cos A will multiply with my cos A to give me cos squared A. Can you see? Then this cos A also, it will multiply with sine A. Then it will give me cos A sine A. Can you see? Then my sine A with my cos A, it will give me sine A cos A. Can you see? And also my sine A with my sine A, it will give me sine squared A. Can you see? Okay. So under here, I have cos A minus sine A, cos A plus sine A. Don't forget, I think you learned in grade 10 that if you have x plus y and you have x minus y, you don't really need to. You can multiply this one with this one, this one with that one with that one, or that one with that one, like that, and you add and subtract the like terms. Okay, but if really you have the same expression, but it's just that their signs are different, this one is plus and this one is minus, what you can do, you multiply first with first and you multiply last with last, right? But I'd really advise you to use the long method, because sometimes some of the learners might make mistake even though they are given something like this. Then they will think, multiply first with first and last with last, and that's not the case, right? It's only the case when you have the same expression but then their signs are different, plus and minus. So even in this case, I have the same expression but with different sign, plus or minus. So I'm gonna say first times first gonna give me cos squared A, then negative and positive is gonna be negative. Sine times sine gonna give me what? Sine squared A. Can you see? Sine squared A. Now I can simplify this. Look at this. I have cos squared A there, and these are like terms. Can you see? These are like terms. Sine A cos A plus sine A cos A. They're gonna give me what? 2 sine A cos A. Can you see? 2 sine A cos A plus what? Plus sine squared A, all divided by cos squared A minus sine squared A. Cos squared A minus sine squared A. It's a rule. Can you still remember the rule? This one is what? Is double angle for cos. So I can change it back to be cos 2A. Do you still remember? So I'm just going to put it on top here. Let me just, because of space, let me just write it somewhere here and continue. So I have my cos squared A. Look at this. I have 2 sine A cos A. It's also a rule, right? I can change it back. We divide by 2 and we double the angle for sine. And it will be what? Sine 2A. Can you see? Plus what? Plus sine squared A. All divided by cos 2A, right? So let me simplify that. I have my sine squared A there plus cos squared A. Remember the identity. Sine squared A plus cos squared A is the same as 1 plus what? Plus sine 2A divided by what? By cos 2a. So we actually proven that indeed our right hand side is also the same as our left hand side. So this is the second method that you can use, different method obviously, that you can use to prove that really that other side is equal to that one, and we call this rationalizing the denominator. So I just rationalize the denominator. In other words, I multiplied with my denominator, then I just changed its sign then in order to prove that. Okay, let's come to B. So B is a follow-up question. It says hence, and I already told you that whenever you are given the word hence in a question, they want you to use the previous question. The previous question A should guide you in order to get the answer of this question, right? So they said hence calculate cos 15 degrees plus sin 15 degrees over cos 15 degrees minus sin 15 degrees without the use of a calculator. Okay, so you can see that really if we let our A to be 15 degrees, right, you'll notice that that expression will be the same as this one. Can you see? It will be exactly the same as this one. And we know it means we can now conclude that cos 15 degrees plus sin 15 degrees divided by cos 15 degrees minus sin 15 degrees is the same as what? Is the same as this side, because we have just proven it. Hence, they use the word hence. Okay, so it's the same as 1 plus sin 2a. Our a is what? Is 15 degrees divided by cos 2 into what? Into a, which is our 15 degrees. So we can simplify that one. 1 plus sin 2 into 15 is 30 degrees plus cos 2 into 15, it's going to be what? 30 degrees. Look at this. These are special angles. Hence, they said without the use of a calculator, then we can get the answer 1 plus sin 30, 1 over 2, right? Cos 30, root 3 over 2. And then we can simplify that one. Which side can I use now? Okay, let me just put it this side. Sorry for the disorganized page, sorry about that. So it's 1 plus 1 over 2, then it will be my lowest common denominator is 2, then it's 2 plus 1, then it will be 3 over 2, then I'm dividing it by root 3 over 2. So it's 3 over 2. If I change my division into multiplication, 2 is gonna go on top and root 3 under there. So 2 cancel out with 2, I'm left with 3 root 3. So that will be the answer of my cos 15 plus sin 15 over cos 15 minus sin 15. So if they give you a question and they say hence, it's much easier to prove, because you just need to relate that question with the previous question, then you'll be able to solve it. Okay, great stuff. Let's now focus on the second part of this session, and I want us now to shift to focus on how you can solve trig equations and general solutions. Although I've already covered this in another session specifically for solving trigonometric equations and general solution, I'll also attach the link. There's a video specifically for this, but now I really see the need for me to repeat this using the knowledge of compound angle identities and also double angle identities. Okay, so I'll just show you some few examples. Some of them I'll just make them to be fun activity exercise, and then we'll conclude this session. Okay, so here's our first question. They say solve for theta, and you are given if cos theta cos 24 degrees plus sin theta times sin 24 degrees is equal to 0.715, and theta is the element of minus 90 degrees included up until 90 degrees included. Okay, so in order to solve for theta there, I can first simplify that expression there, right? Cos sin. Can you see something? Cos sin. So this one is compound angle for what? For cos, right? It's compound angle for cos. So it will be cos theta. Because it's positive for cos, we change the sign, right? So because here the sign is positive, here it's gonna be what? Negative. Then 24 degrees is equals to 0.715. Then I believe from there you can solve for theta, right? So theta minus 24 degrees will be equals to, remember the rule for cos, I think we covered that in that session, but let me just repeat it also. If I have cos theta equals to m, so the rule for cos says theta equals to plus or minus arc cos m, right? So even here I want to solve for this. Theta minus 24 would be plus or minus arc cos 0.715, right? So we can have theta minus 24 degrees is equals to arc cos 0.715, or theta minus 24 degrees will be equals to negative arc cos 0.715. Okay, so we can go and solve for theta there. Theta minus 24 degrees, what is our arc cos 0.715? On the calculator I'm getting 44.36. So this is 44.36. So theta minus 24 degrees, it will be what? Here it will be negative 44.36. Okay, so I can solve for theta this side by taking my 24 to the other side to be 44.36 plus 24, right? When I add 24 to this side, it's gonna give me what? 68.36 degrees. So let me just also use the general rule for cos to say plus k times 360 degrees, where k is the element of all integers. Or this side, when I take my minus 24 to this side, it will be positive there. Minus 44.36 plus 24, right? To be plus 24, it's giving me minus 20.36 degrees, right? Minus 20.36 degrees. If I use the rule for cos, to be plus k times 360, where k is the element of what? Of integers. Where k is the element of integers. Okay, so remember there's a restriction here to say your theta must be between minus 90 and 90, right? And you can see minus 20.36 is part, and also 68.36 is also part. So to get all those other values of k of theta that are between minus 90 and 90, where there is k, you're gonna substitute by minus 3, minus 2, minus 1, 0, 1, 2, 3, right? Where there is k, you're just gonna go there and substitute those values. You punch your calculator and you get the answers, and you check whether the answers that you are getting are between these intervals. Same as on this one, you're just gonna substitute minus 3 where there is k there, substitute minus 2, you also substitute minus 1, 0, 1, 2, 3. You substitute them where there is k, and you punch your calculator, you get the answers, and you check whether they are between minus 90 and 90. So if they are between, then you're gonna write them down as your values of theta. Okay, let's now go to B. It says show that if cos theta plus 30 degrees is equal to 1 over 2 sine theta, then tan theta is the same as root 3 over 2. So they're saying that if that one is equal to that one, then this one will be equal to this. So let's use our given information. We're given that cos theta plus 30 degrees is equal to what? 1 over 2 sine theta. Then we have to prove that indeed tan theta will be the same as root 3 over 2, right? So we have to use this given information. So we can see this is compound angle for what? For cos, right? That is compound angle for cos. Then it will be cos cos sine sine. So it will be cos theta cos 30, but when it's positive for cos, we change the sign to be negative. Then it will be sine theta sine 30, right, is equals to 1 over 2 sine theta. Okay, so this will be cos theta. What is cos 30? Is the same as root 3 over 2 minus sine theta. What is sine 30? Is 1 over 2. Then this is 1 over 2 sine theta. Okay, so we have root 3 over 2 cos theta minus 1 over 2 sine theta, right? So I can also take this 1 over 2 to the other side. So it will be minus 1 over 2 sine theta. Then I'm left with 0 there. Okay, can you see? So we have root 3 over 2 cos theta minus 1 over 2 minus 1 over 2. It will be minus 2 divided by 2. Then it will be minus 1. So I'll be left with minus sine theta is equals to 0. Can you see? Then what can I do now? What I can do, I can take the sine theta to the other side, right? So I'll be left with root 3 over 2 cos theta, this side, then is equals to what? Is equals to sine theta. Remember, we have to prove that indeed tan theta is the same as root 3 over 2. So in order to prove that, using the given information, I'm going to divide both sides by cos theta. Why cos theta? Because I know that sine theta and cos theta will give me that tan theta there. Okay, so divide both sides by cos theta. Yeah, I'm left with root 3 over 2. Sine theta over cos theta is what? It's tan theta. So we have proven that indeed, if we are given that cos theta plus 30 is equals to 1 over 2 sine theta, then this shows that also we can prove that tan theta is equals to root 3 over 2, and we just did it there. Okay, let's go to number 2. So on your number 2 from B, it says, hence find the general solution for cos theta plus 30 degrees, which is equals to what? 1 over 2 sine theta. Find the general solution for that. So if I already tell you, if they use the word hence, they are saying your previous question should help you to answer this question. Okay, so what did we do on the previous question? We used this expression exactly like this, and we were able to deduce that tan theta is equals to root 3 over 2. So in order to find the general solution, I don't need to first expand again and do all this. I already did it in the previous question. Hence, they are using the word hence to show that what you did in the previous question should help you to answer this question. So I'll just go straight here, because when I simplified that thing, when I expanded on the previous question, we got tan theta is equals to root 3 over 2. Then we can get the general solution. So theta will be the same as arctan root 3 over 2. Arctan root 3 over 2. Arctan root 3 over 2. Okay, so the answer will be 30 degrees, right? So this will be 30 degrees. So we know the rule for tan. So let me just remind you a bit. If I have tan theta equals to m, then theta is going to be what? It's going to be arctan m plus k times 180 degrees, where k is the element of all integers. So this is 30 degrees plus k times 180 degrees, where k is the element of all integers, because they said find the general solution, right? We can also go where tan is positive. Tan is also positive on the third quadrant, and it's defined by 180 degrees plus theta. Can you still remember? On the third quad, where it's defined by 180 degrees plus theta. So our theta can also be written as 180 degrees plus theta, which is 30 degrees plus k times 180 degrees, where k is the element of all integers. So for tan is 180 because its period is 180, right? So 180 plus 30 is going to give me 210 degrees plus k times 180 degrees, where k is the element of all integers. So that will be the general solution there. Okay, let's just also quickly do these questions on solving trig equations and general solution, and this one is for general solution. Let me just quickly show you how you can do this, and just give you a fun activity, and we end this session. Okay, so it says find the general solution of A. You are given sine 2 alpha plus 2 sine alpha is equals to 0. Okay, so here definitely you change this one. It's double angle for sine. Obviously it's going to change into 2 sine alpha cos alpha plus 2 sine alpha is equals to what? Is equals to 0. And you can see we have a common factor of 2 sine alpha both sides. Gonna take 2 sine alpha, then I'll be left with what? With cos alpha plus 1 is equals to 0. Then I'm going to use 0 factor rule to say 2 sine alpha is equals to 0, or cos alpha plus 1 is equals to 0. So here I'm going to divide by 2. It will still remain sine alpha is equals to 0, or cos alpha is equals to what? Minus 1. So when I do this one, I'm just going to use the rule for sine to say alpha is equals to arc sine 0 plus k times 360 degrees, or alpha is equals to, remember the rule for sine, it's also 180 minus into arc sine 0 plus k times 360 degrees. Then you can get the answer for that, right? For cos to be alpha is equals to plus or minus arc cos minus 1 plus k times 360 degrees. Then you can simplify that and solve that, right? So because of time, let me just end it there. Sorry about that. Let me just end it there so that you can complete that one. Let me just go to the second one, B. So on your B, you are given 2 sine squared alpha plus sine alpha is equals to 3. So you can see that this one is squared and we have sine. It's sort of like in a quadratic equation way, right? So I'm just gonna write it properly to say 2 sine squared alpha plus sine alpha minus 3 is equals to what? Is equals to 0. So there are two methods here. You can use the straightforward method of coming and factorizing this one, right? And I think this method is quite complex for many of you learners. So but you can use it to say, you can factorize to say 2 sine alpha, then sine alpha here, and then you see how can I make this to be positive 1 here in the middle, right? So these 2 must multiply with 1 so that it can be minus 2 sine alpha there to be minus 2 sine alpha, then 3 should be positive so that this one it is 3 sine alpha minus 2 sine alpha, we get positive 1 there, right? So then you can just use 0 factor rule and solve. So but if you don't know how to factorize, you can just check your equation, your trigonometric equation. It's in a form of a quadratic equation. Can you see a parabola like that? So you can just let sine alpha to be what? To be x. Then where there is sine alpha, you put x. So that one is squared, it will be 2x squared. Where there is sine alpha is x minus 3 is equals to 0. And you can use a quadratic formula to get the value of x, right? So to say x equals to minus b root of b squared minus 4ac over 2a. So this is quite a long method, but it's a safe one because you don't want to make a mistake by factorizing and you find that you are not factorizing correctly, right? Then you can go, you solve for your x, you come back here, you substitute your two values of x, then you're gonna solve that general formula. Okay, let's quickly go to C. Okay, C, interesting. You are given cos 2 alpha plus cos alpha is equals to 0, right? You have cos 2 alpha plus cos alpha is equals to what? Is equal to 0. How can you solve this? So you know that this is double angle for cos, and it can be changed into 3 things, right? But before changing, you must connect with the whole equation to see if this will work. So when you change it, really, you're gonna look at this one. You definitely need to change it into being cos cos alpha, right? It must if you are able to express that one into cos alpha, then you'll be able to solve, right? You can't change it into sine. You complicate your equation, so just change it to be the same as what? As that one, which is cos alpha. And we know if I want to change it into cos alpha, cos 2 alpha is gonna be what? Is 2 cos squared alpha minus 1, right? Then I have plus cos alpha is equals to 0. So we have 2 cos squared alpha plus cos alpha, if I write it properly, minus 1 is equals to what? Is equals to 0. Same as this. It's sort of like a quadratic equation. Can you see? So what you can do, you can just let your cos alpha to be what? To be x. Or you can factorize if you know how to factorize, and you can just go straight and get the answer, right? So for the purpose of those who might not know how to factorize, you can use this method. Let cos alpha equals to x. There where there is cos alpha, you're gonna put x, and it will be, because it's squared, it's gonna be x squared, plus where there is cos alpha, x minus 1 equals to 0. Then you're gonna solve for x using your quadratic formula, because this is a quadratic equation. You write your quadratic formula. So for x, you go back and substitute your value of x, then you can solve the general formula for cos there. So that's it. Okay, here's your fun activity exercise, and let's see who can get this. So it says solve for alpha if 1 plus sine 2 alpha minus 4 sine squared alpha is equals to 0, and alpha is the element of minus 80 degree included to 90 degrees included, right? So let me just give you a hint on this one. Obviously you're just gonna change sine 2 alpha into its role, right? Also, after changing it, you're also gonna change 1. You know that there's an identity for that. After changing, group the like term, add the like term, see if you can factorize. If you can't factorize, you can let sine alpha or something like that to be x, right? But on this one, I think it will be impossible for you to use that method. So just try to factorize and be able to solve for alpha. Then after solving for alpha, you must be knowing the rules for sine, for sine and also for cos, right? So that the general rules, those one, and I just covered them in another session where we were strictly focusing on solving trigonometric equations and general solutions. I'll just post the link on the description where you can just go and watch and conceptualize that knowledge. Remember, here you're given a restriction to say your alpha is between what? Is between 180 degrees and 90. It means after calculating those alpha, you must go and substitute your values of k there, minus 3, minus 2, minus 1, 0, 1, 2, 3, and take the answers that are only between this interval. Then you definitely have solved it. Okay. All right. Thank you very much, guys, for being with me, for joining me in this session. Thank you very much for watching, and that's all for this session. It was our part 5 where we were focusing on proving trig identities and also solving trigonometric equations and general solution. So our next session will be our part 6, where we'll be focusing on solving 2-dimension, I think also in 3-dimension trigonometry, where we're going to use the sine rule, cosine rule, and area rule in order to calculate those different trigonometric questions. Okay, otherwise for today, that's all for me. Thank you very much for watching. Thank you for joining. Enjoy the rest of your day, and goodbye.